It is a pleasure to welcome you all to this brown bag lunch or BBL on sustainable performance, operations, and maintenance of nature-based solutions. I was able to introduce myself to some of you this morning, but there are quite a few other colleagues that are here today. So I just did want to take this opportunity to reintroduce myself to you. So my name is Sebastian. I'm the Director for Strategy and Operations for the Infrastructure Vice Presidency here at the bank. So again, I wanted to welcome all of you to this BBL, as I just said, organized by our own GFBRR, as well as the Global Program for Nature-Based Solutions for Climate Resilience, in close collaboration, of course, with all of our international partners that are joining us here today. And I'll mention them in just a minute. The Global Program on Nature-Based Solutions, or NBS, sort of a core thematic area of GFBRR, sort of really is here to provide technical assistance and support to task teams and our clients as well, I should say, to really help enable and increase the integration of NBS in climate resilient investment. So in other words, in each of our projects and in the work that we do on behalf of our clients. And really it's here to, number one, to provide direct support to our task teams, right? But it's also here to develop knowledge products, sort of cutting edge knowledge and sort of the latest lessons learned. And then also, and this is important, on-demand analytics, such as the NBS opportunity scan that some of you may be familiar with. And these program sources are, of course, scarce, but the good news is that they're also available, and we put them at everyone's disposal on naturebasedsolutions.org as well. So everyone can make good use of those resources online as well. But really today, why we're here and the purpose of this BBL is to really hone in and to focus sort of on the critical role that effective O&M, so operations and maintenance, plays in ensuring for sustainable performance of nature-based or NBS solutions for climate resilience. That we really want to learn about some of the cutting-edge O&M practices from our external partners, right? I think it's really important that we not only always, have this internal focus and learn from ourselves, but also learn what's happening elsewhere, in this world in terms of what good practices are, and really take advantage of their presence here this week as part of the international working group on NBS that the World Bank group is hosting. And these international partners that are part of the IWG, this international working group, include agencies from both sides of the Atlantic, right? So we have the U.S. Army Corps of Engineers that is here, the NOAA, the Dutch Rijkswaterstaat, and the Environmental Agency from the UK as well. So we're really happy to welcome again, our partners here today, and that they are able to share some of their lessons learned and experiences as well. We will first hear about some upcoming guidance and a piece on O&M on NBS that we are developing. So, the World Bank is developing with this IWG. And we have several speakers that will be talking about that, and we're going to hear presentations that are going to focus on coastal, riverine, as well as urban NBS projects from around the world in this respect. We've asked the speakers to really focus in and hone in on lessons learned and recommendations relevant for multilateral development banks, MDBs, that are investing, such as, of course, the World Bank, but also other project developers. And we really hope that this is going to prove to be a good interactive and dynamic session. So I'm really going to count on all of you to probe, to challenge, ask constructive questions, and really so that we can have a dynamic, session, and we don't fall asleep after our nice BBL and die a thousand deaths of PowerPoint, so to speak, right? So please let's keep this dynamic and active, right? We'll also have a discussant, our own Paulo Strepo, who's going to sort of reflect on a case study presentation and as they relate to World Bank operations and then the wider sector context as well. And so with that, let's begin. But before, I do understand that we have a video message that's still on, right, from Mike van Ginneken, who is the water envoy for the Kingdom of the Netherlands, who's here. Well, not here, but we have a video message, and we'd like to beam that to provide us with some inspiring, messages to kick things off. So I don't know who has the. Yep. So let's hear from Mike.
A warm welcome to all of you. It's an honor to address a subject that's vital to our collective goal of building climate resilience. Operation and maintenance of nature-based solutions. As Water Envoy for the Kingdom of the Netherlands, I have the privilege of working with partners across the globe to raise awareness, foster collaboration and share knowledge on innovative water solutions. In my experience, I've seen how nature-based solutions can transform landscapes and offer sustainable protection against climate challenges. Let me talk about the importance of operation and maintenance. Nature-based solutions are powerful tools for mitigating climate risks, while also restoring ecosystems and supporting communities. In the Netherlands, we face significant water challenges due to climate change, soil subsidence, environmental pollution, and increasing spatial pressure. As we look for solutions, NBS must play a vital role. We've witnessed the benefits of solutions such as dune restoration, floodplain management in protecting against floods, while enhancing biodiversity. For example, in the Room of the River project in the Dutch city of Nijmegen. We also see promising opportunities to use nature-based solutions for replacing or upgrading outdated infrastructure, complementing traditional grey approaches. However, it's vital that these solutions must be carefully maintained to ensure their long-term effectiveness. From my experience managing water and energy portfolios at the World Bank from Africa and Asia, FLIRT and O&M is not just a technical necessity. It's the foundation for sustaining interventions over time and adapting them to changing conditions. Effective planning for maintenance from the earliest stages of development can help to reduce the hesitation to implement nature-based solutions. And for that, we need global collaboration and learning. So today's session is a crucial step toward advancing our understanding of maintaining nature-based solutions. In my role as Water Envoy, I advocate for the importance of global collaboration in addressing complex water challenges. The Netherlands and our public work agency, Rijkswaterstaat in particular, is proud to partner with the World Bank, the US Army Corps of Engineers, the Environmental Agency, NOAA, and other international organizations to share best practices and expertise. By working together, we can ensure that maintaining NBS is as robust and effective as their initial design, so we help communities worldwide to remain resilient in the face of evolving climate threats. I'm sorry that I'm unable to be with you in person today, and I look forward to hearing the outcomes of this session and the insights it will bring. By continuing to share our collective knowledge, we can strengthen the role of nature-based solutions in our climate resilience strategies, and we can ensure their success for the long term. Thank you.
Presentation again. I understand that Daphne and Matisse have a presentation for us ready, so I'll send it over to the team to begin.
Great. Okay, thank you. I think it works. I can see the slides here. So yeah, hello everyone. Thank you for joining us. And thank you, Sebastian, for the nice opening remarks and introductions. Also on behalf of the World Bank's Global Program on Nature-Based Solutions and GFDRR, I'd like to welcome everyone to this session, both in person here with us today, as well as to our audience online, and especially a warm welcome to our partners from the International Working Group on Nature-Based Solutions. We are excited about this session today around the operations and maintenance of nature-based solutions that we organize together with our partners. And Matthijs and I will start with a brief overview of our upcoming guidance note that we're developing with the partners. But we will keep this intro presentation relatively short because we will be hearing from our speakers working in actually implemented NBS projects, which is pretty exciting. So first of all, for the people not maybe so familiar yet with nature-based solutions, for some of you it's probably already a well-known slide, but this is what nature-based solutions actually are. So it's the definition. NBS are natural solutions that provide benefits for climate resilience, biodiversity, and human well-being simultaneously. And it's an umbrella term. So as you can see here in this image, NBS can appear at various sizes and scales, from smaller parks and bioretention areas in cities to coastal mangroves and forests at the catchment scale. And because of these multiple benefits of nature-based solutions, interest for these solutions have grown globally, including at the World Bank. And this image on the left shows the trend of World Bank NBS investments from 2012 to 2023, with over 200 projects with NBS components valued at an estimate of more than $10 billion. And these projects have, for example, been restored ecosystems and protected coastlines and riverbanks across regions. Though through the GPNBS, as you can see here on the right, we are working actively to mainstream NBS across World Bank projects, and our efforts have really been contributing to the increase of NBS at the World Bank. And we did that through 3 pillars that we're working across. So we develop knowledge, where we identify knowledge gap on nature-based solutions. We provide operational support with the integration of NBS in actual projects from the World Bank, and we foster partnerships. So we work with partners like the International Working Group here during today to be updated on the latest development around nature-based solutions. Next slide, please. So despite the growing demand of nature-based solutions, there are still several challenges that prevent NBS to be implemented. One of these challenges that we come across often in our work is around the operations and maintenance of nature-based solutions. This is really seen as a significant knowledge gap when we talk to teams or World Bank teams and governments around the world. And even when client governments of the World Bank understand the potential of nature-based solutions and investment options, they can still hesitate to implement them when they are uncertain about their O&M. So we come across questions such as, how do we maintain NBS over time? What equipment is needed? Do we need trained staff? How do we build capacity among stakeholders? What does it cost? And how do we secure long-term financing, especially in the World Bank case when a project is closed? And finally, who is responsible for operations and maintenance? And to address these questions and learn in detail about operations and maintenance, we turned to our International Working Group on nature-based solutions because of their extensive experience as implementing agencies, so including Rijkswaterstaat, the US Army Corps of Engineers, Environment Agency, and NOAA. And we explored how we could develop a very practical O&M guidance note for NBS together. And we are happy, of course, that we are here together today to show you our advancements of this report. It is expected to be published next April. You see here on the right that we structured the report in 2 parts. We have O&M principles, providing general lessons for maintaining NBS, and secondly, case study fact sheets. And these fact sheets are actually the heart of the document, as they showcase existing World Bank and external partner projects with existing O&M plans around the world, including urban, coastal, mountain, and river nature-based solutions. So we cover all the different types and skills of NBS. And our hope with this guidance note is that it provides governments at the World Bank and other governments and project developers globally with a useful reference in developing their own O&M plans for NBS, and with that implement NBS with more confidence. So our case study speakers here today are all authors of a project fact sheet. They will take us through their NBS project O&M insights today. But before we listen to these exciting case studies, Matthijs will provide you some additional details about our report, including some O&M principles. So thank you, and over to you, Matthijs.
Is it now? Okay. All right. So yeah, next slide, please. So operation and maintenance is part of asset management. And asset management means actually all the activities that bring value to an asset, and this value can be flood safety, can be nature development, can be investments in, for example, other kind of. So all in all, if you go through the asset management cycle, we have the acquisition, the design and build, operations and maintenance, and the end of life decision. So there can be renewal or disposal. So, but if you look to this kind of statements, then acquisition, oh wow, we're going to buy land. So, and design, oh, we're going to design something. So it's also interesting. End of life cycle, oh, we have to be creative. What we do with our leftovers, but operation and maintenance, okay, we keep how it is. So sometimes maybe it's a little bit less interesting. So please, the next slide. Okay, hit it. But it's not correct because O&M gets less attention. But if you look to operation and maintenance, it spends for decades, so it can spend for a long period of time. The cost can often outweigh the investments in the beginning. And O&M is often seen as a cost, but in the end, it's not a cost. It's also a way to save money in the end. So that's not really true. That it gets less attention. In our report, we want to look at how we look at an NBS asset, but then we want to use the existing procedures. For example, you design for safety and for reliability, and you design for maintenance. So we want to keep the original procedures. If you think about NBS, for example, also risk matrix, you can also use one NBS. So next slide, please. What's the difference when you think about an NBS asset? In general, you can say that the behavior of the asset is unclear in the beginning. Maybe you don't know yet how it will develop. So you need a strong monitoring program in the beginning, in the initial stage. I was part of many monitoring programs, and I thought also it's a very great opportunity for students. This is a picture from a while ago that we were a student at this Set Nourishment, so it's a great opportunity to learn for students. Another differences with NBS assets is that they have a less sharply defined boundaries. It's nature, it can be bigger, it can be small. It's not only a levee, but maybe it's also the foreshore, so it can be much bigger. And secondly, NBS assets can change over time because we deal with soft material, but also nature can change. It can grow, it can decay. So there are more changes we have to take into account when we think about asset management. In general, you can say that NBS assets are maybe more complex and there are more stakeholders involved. And in these guidelines, we want to help how to deal with these differences. So the next slide. Yeah, so we have definitely already talked about the fact sheets. So these are an overview of the 3-page fact sheets. We have around 10 to 15. And in this session, we will talk about 4. So next slide, please. And this is a bay lagoon area in United States, a riverine project in the Netherlands, an urban project in India, and a coastal project in Indonesia. And I think we now will start with Tom Wilms, who will introduce his case at the mangroves in Indonesia.
So thank you so much. So let's begin with Tom. So Tom Wilms is a hydraulic engineer who has extensive experience in coastal and river basin solutions and who's working for EcoShape and Viteven and Bos. He's also worked on notable projects in Indonesia, including the award-winning mangrove restoration in Central Java. So Tom, over to you, please, for your presentation.
Thank you very much for the introduction, and also thank you very much for having me here. In the coming minutes, I will share some information about the mangrove and aquaculture revitalization project in Indonesia, which started in 2015 and ended 7 years later. So that was a really long project, was really nice. And in this image, I think a lot can be seen. Alternative livelihood in the front, old structures that weren't that sustainable or durable as expected. Biodiversity coming back, birds, a monitoring pole in the end, and the permeable structures that were constructed to bring back mangroves. So this one picture shows a lot, and in the coming slides I will talk you through the project and the different elements, mostly focusing on monitoring and maintenance. There wasn't that much operation. Let's see if I can go to the next slide. Building with Nature Indonesia. It is in Indonesia, on Central Java, in the district Demak. And these are already the key messages I want to share with you. In this project, we did thorough system understanding and early stakeholder involvement. And over those 7 years, that resulted in sustainable design solutions, which provided higher vital benefits, reductions in cost, and also a faster institutional process. The image in the middle shows the benefits of the mangrove forest, which is much more than only coastal protection. It is also tourism, purification of water, carbon storage, timber and fuel, and fisheries. The numbers are estimates. They're not wild guesses. We did quite some research to find those values. And I think it's still values for 2015, so not actual. And on the right, you see all the organizations involved in this project, which are a lot. But I think you need all of them to get to a sustainable project. And it was led by EcoShape, a Dutch consortium. It's a Dutch partnership with, for each project, a different consortium, including Wetlands International. So those two were in the lead for management. A bit about the project. The vision we had at the start, and which we were able to achieve as far as possible, was a cyclic or an iterative vision, because you need a prosperous local economy to enable the maintenance of the mangrove green belt. But you also need the mangrove green belt to provide coastal safety for the enabling economy to prosper. So it's not only protection or only production, they go hand in hand, and that is what we did in the project. But I will focus mostly on the mangrove greenbelt and even on the temporary permeable structures. So where is the project? It is in Indonesia, on the island of Java, and the area shows the coastal area of interest. It used to be paddy fields, rice fields, which were later converted to aquaculture ponds, and that's on the right image, you see the coastal retreat. So in roughly 10 years, the coastline retreated at some locations up to 2 to 3 kilometers. So also some villages were lost, and people need to be relocated, as you see in the images here. On the top, you see houses flooded and within the mud. So those people had to be removed. And the challenges the project area had were coastal retreat due to cutting of mangroves, but also colonization. The area also had a lot of flooding, as you see, a decline of aquaculture productivity, and as a result, some people had to be relocated. So various problems caused by different root causes. So we first did a thorough system understanding and continued with that over the entire project, but also looked for alternatives for coastal protection. And we learned that both hard structures as well as mangrove planting often don't work in muddy systems or in coastal systems. But we also looked at successful alternatives which were used in the Wadden Sea in the Netherlands, permeable structures that trap sediment, and over time the area heightens. So that is what you see at the right. Also there it was learning by doing. We improve the structures every year. We build new structures every year, but every year we also learn from the structures we built. So the structure at the right, that was built, I think, always before stormy season, and after 2 months, the sediment at the right side was even already above low water level or mean sea level. In the middle image, you also see, I don't know if the mouse is working, the permeable structures as well. Behind sedimentation takes place, and also mangrove patches come back. So the focus now for the remaining minutes will be on the monitoring and maintenance of those permeable structures. So the monitoring was done on various spatial levels. We have, for example, here a monitoring pole to monitor sedimentation rates before, behind and in front of the permeable structures. We also monitored the structures itself, as well as the elements of the structures. So the vertical poles, the horizontal beams, the fill material, the wire that was used to keep it strong. We also did, and everything we did together with the field team, local people, so where to build new structures. We did tests, how to build it, so also new contractors, because this was a new structure they hadn't built before. Both contractors as well as the team joined the training to see how it works. So these were also for me the very first poles that were placed into the mud. So that was done all manually. So by jumping on a horizontal beam, poles were pushed into the soil. And local communities were involved from the very first start, not only for construction, but also inspection of the materials. So all the materials that arrived need to be checked. Monitoring is not only done spatially, but also in time. Monitoring was done already during construction to see if all the materials were deep enough, strong enough. And an additional check was done before the storm season. So in Indonesia, that was in October, November. So repairs could be done in time so that there was a strong structure when storm season started. After storms, monitoring needed to be done to do the repairs. And that is the bottom part as well. Maintenance was mostly on elements. If poles were damaged, they needed to be replaced. If fill material was washed away, it needed to be replaced. We developed monitoring plans and maintenance plans.
Tom, sorry
Yes.
to interrupt. I just want to be conscious of time. So we every speaker has about 10 minutes, and you're about at 2 minutes left or so, or 1 minute left. So if you could just keep that in mind. Thank you so much, and my apologies.
No, very good. Thank you very much. Then I will speed up. Challenges were that there was shipworm, so the poles were eaten. So we moved to bamboo, but we also had other learnings. We also moved to PVC poles in the end. Financing part, this project was funded by Dutch government and German government. We made some papers also about cost. So this shows construction cost and maintenance cost. And maintenance cost per year was roughly half of construction cost. As I said, local community did a lot. They owned the structures. They were involved in every phase, and they also advocated, lobbied for financing from local governments, which they received. And because the permeable structures bring back mangroves, there are a lot of revenues, which was part of the vision as well. So aquaculture provides revenues, tourism, and also products from the forest. And this is my final remark. So what I already mentioned at the start, but the bottom two lines are, it's learning by doing, and it also requires from all participants adaptive planning cycle. There's much more to tell, much more to read. There are multiple documents and guidelines we provided, so those can be shared. Thank you.
Thank you so much, Tom. Really a great presentation. And also really appreciate the lessons learned. The good news is everyone sees your website, and for further information, don't worry, we know where to find you, and we'll be coming to ask you any questions. So thank you so much, Tom. So let's move on to the next case study. And we have Terry Marks, who's joining us. So Terry is a project manager with the U.S. Army Corps of Engineers, where she leads innovative, climate resilient and infrastructure projects, and her exemplary work on the Hamilton Wetlands Restoration Project earned her the Assistant Secretary of the Army for Civil Works Point for Excellence. So we really look forward to the presentation, Terry, and look forward to your learning and your sharing the experience. Thank you. Terry, over to you, please. You have about 10 minutes, if that's okay. Thank you.
Got it. Got it. Thank you, everybody. Let me just share my screen here. And, I'm going to turn off my camera for the presentation. All right, I'm going to assume I haven't heard anything bad, that you can all see this. Thank you so much, and welcome to the Hamilton Wetlands Restoration Project. The project's located about 30 minutes north of San Francisco in California, here in the United States. And it's a two-part project, wetland creation at a former Army base and the beneficial reuse of dredged material. The project is composed of 3 different sites, and once completed, it'll restore about 2,000 acres. But I'm just going to focus on the Hamilton Army Airfield project here. The project is located, like I mentioned, here in the San Francisco Bay. And why? Why did we have to do this? Well, since 1850, the San Francisco's Bay has lost about 90% of the Bay wetlands. And on the map here, you can see the smiley face is San Francisco, and the pink star is our project location up in the North Bay on San Pablo Bay. And so what happened in 1849 is that they found gold. They found gold in California, and there was the big gold rush, and population increased dramatically. And at that time, and population here in California has done nothing but increase dramatically since then. And in the San Francisco Bay, people moved, and everyone started reusing the bay and repurposing it for other uses: military, agriculture, salt protection, even landfills. And so you can see the yellow on the map is where the wetlands used to be, and the green shows where they were in 1995. And what happens when you separate the bay from the wetlands from the bay, the bay mud, it subsides, it shrinks. And so then what happens is that we start the San Francisco district then also has a mission to dredge the San Francisco Bay and keep it open for commerce. And so that's one part of the project. And then the other part is we have all these wetlands that have subsided, and they've subsided below the levels that are useful. So then what we did is we married the two, and we have the beneficial reuse of dredged material. And so that was one of the key components of this project, is reusing the dredged material to provide the sediment necessary for the project to create the wetland. Okay. So in 2014, the site was breached and construction was complete. And real quick for what they did for construction is, these deep dredgers go out and they dredge the channels in the bay, and then they need to bring it to the site. But the problem is that the San Francisco Bay, particularly in the North Bay, is notoriously shallow. And so they couldn't get the dredgers in close enough to offload the material. So where the blue X is in the map, they had to bring out or create a offloader. So the dredgers would come to the offloaders, then offload the material, and then they had to pump the material 5 miles to the site. And so once they get the material to the site, then they can raise the grades, and this is going to help Mother Nature create a wetland faster, much faster than if we just opened the site to the bay. And then from there, we started to shape the wetland features. So what are the features? What did we create? We created tidal wetlands, seasonal wetlands, transitional upland habitats, the perimeter levees that contain the site and the sediment and the tidal bay. We breached the site to the bay. We created a native plant nursery, and we also added a recreation component, 3 miles of what's called the San Francisco Bay Trail, the Bay Trail will eventually encompass the entire bay and will be 500 miles. And so then, okay, so we breached the bay. Then what happens next? That's where our monitoring and adaptive management comes into play. And this is where we had many different people and resource agencies, regulators, long-term stakeholders who wanted and had their own opinions about what the project should be and what it should look like. So we got them all together and we put together a plan. We have a 15-year plan for monitoring and adaptive management. And the plan outlines the management structure, the monitoring activities, and our performance criteria. And so right now we are just starting our 11th year of monitoring. And so what happens when we do all this monitoring? We do this annually, and we put together a report. We have an annual monitoring report. And then this report is provided to all the regulators, whoever wants to see it, but we have what we call a technical advisory committee. And this committee gets together every year and we review the report, and we determine where the project's going, how it's performing, what's underperforming, what's doing great, and we plan to move from there. And so what were our targeted benefits here? Our targeted benefits are essentially 80%, create 80% tidal wetlands, 20% seasonal wetlands, ensure no net loss of wetland habitat, and sustain our wildlife populations. And one of the key factors that I really want to emphasize is there were additional considerations, and that one that is very important is to prevent invasive plants. We have a very large problem with invasive plants. And so another part of the plan is the performance criteria and the monitoring metrics. We have 4 distinct categories, which are further defined by the habitat type of each project feature. And so what are we monitoring here? These are our habitat types, our locations, and our parameters listed here. And these are monitored in various different forms for each year. Our challenges, successes, and lessons learned, we have many, and this is not an exhaustive list. We are working on a final lessons learned report, but one thing I do want to note here particularly is that this project benefits from a significant investment in monitoring and adaptive management. And it's very true, but it's not just monetary, it's also the community and the regulators have a large investment in the project. One success story that I particularly wanted to point out, which takes into account monitoring, adaptive management, and lessons learned, is the Western Snowy Plover. This was not this is a listed species that the project team did not plan for being at the site. It's not favorable conditions for them there. And so they showed up one day. And why did they show up? Well, when the site was constructed, the pink line there, that's our containment burn for the North Seasonal Wetland. It had subsided after construction. So bay mud, San Francisco bay mud, is notoriously compactive, and it just shrinks, and it shrank. And so what happened is the tides started overtopping it, and then we couldn't manage. This is a managed wetland, and we couldn't manage it the way that we wanted it managed. And so what happened is we ended up managing it without managing it, and it was attractive to these little snowy plovers. And they moved in, and they're a listed species. And so you can see there, I don't know if the yellow circle there is shows their nest. They use camouflage to basically survive out in the open. And so we adapted and we started operating for the snowy plovers. Once we had to go in and we raised the berm and we fixed it, and now we operate for them. So it's a really good, nice success story. We have an interim O&M manual. Our project partner, the California Coastal Conservancy, is the project. They do the maintenance on the project, and we only have minimal actual operations, which is these 2 water control structures there in the North Seasonal Wetlands. Maintenance, most of our maintenance is actually performed by volunteers, and that's because a huge part of the maintenance of the project is invasive plant removal and native plant installation. And that native plant installation and maintenance includes a lot of different components, and it takes a lot of manual labor, and all of our volunteers are there all the time. We have an on-site native plant nursery, and one of the key components to this project, the key to success, is the urban location. We are located in a very urban area. Volunteers live nearby. They can come anytime and help out. They do, and this has become a very large community for the project, and they help immensely. This site,
Terry, sorry, just if I can ask you to wrap up in about a minute or two, that would be great. Sorry, I just want to be fair to all the other speakers that are still coming. Thank you so much, Terry.
Yeah, I'm almost there. Community is huge there, and these are just a few pictures I wanted to share with everyone to show the community involvement out there. Financing and funding. Our partners, project partners, basically have to agree to financially support the project before we turn dirt. And they sign a legally binding agreement, and it describes the roles and responsibilities for them to do this work. In our project agreement, it includes the monitoring and O&M, and the first 13 years of monitoring is cost shared between the Corps, the federal government, and our project partner. Years 14 and 15 of the monitoring will transfer to be solely the responsibility of our non-federal sponsor. Project turnover. This occurs with providing an O&M manual. Once construction is complete, the O&M manual has been provided to the non-federal sponsor, and then we're going to update it at the end of the monitoring period to include lessons learned and any adaptive management issues that we need to be addressed, and costs. The total project costs are for the monitoring and adaptive management for the 13 years is estimated to be about $12 million, which is about 10% of the total project cost. And then in closing, I just wanted to share some pictures of before restoration with the original wetlands, and 10 years. This is what it looks like this year, today. Thank you.
Great. Thank you so much, Terry. Really fascinating presentation, and great to see in particular the before and after pictures as well. So let me turn next to our third case study, which is going to be led by Eva Abfanes, who is a director of OOZE Architects and Urbanists, and who leads the City of 1,000 Tanks project in Chennai, India, under the Water as Leverage program. Eva also specializes in strategic urban planning and climate adaptation, and focuses on creating sustainable solutions for complex environments. So with that, Eva, over to you, please.
Thank you for the invitation.
to share our project for the Water as Leverage program of the Dutch government, the City of 1,000 Tanks. So I'm gonna share my screen. And right, so this project was set up as part, it was a competition we won for the city of Chennai as part of the Water as Leverage for Resilient Cities Asia program that was set up by the Dutch Enterprise Agency on behalf of the Ministry of Foreign Affairs and the former Special Envoy for Water, Henk Ovink. Our consortium comprises many different entities, academic, private, NGOs, researchers, and implementation agencies. Our project is in Chennai, in South India, in Tamil Nadu, with a population of 7.5 million people. And here I just show some stakeholders from our very intensive process that started in 2018. So the process of Water as Leverage is set up in a way that design-led consortia produce visions for cities. So that was Chennai, Khulna in Bangladesh, and Semarang in Indonesia. And then there's certain local meetings and meetings that work towards making the projects bankable. So we had also 2 meetings, part of which you see here, with banks in Singapore, such as GCF and World Bank. And at the same time, we worked on locally embedding the process with our local NGOs, with the children program Young Water Ambassadors for the Goethe Institute. We look at context and climate change projections, and one very important one is the interrelation of crisis between too much and too little water. In 2019, Chennai ran out of water. Day 0, water literally had to come in by train. But when we look at the rainfall, this idea of scarcity is actually not necessary. If we understand, even the city of 7 million needs less than nature provides. Our ancestors have dealt with actually constructing temple tanks that are now nearly empty, that are not holding on to water, but function like inverted pyramids, like a recharge tool for the monsoon time. 80% of the soil structure in Chennai is favorable to actually create, eventually the asset here is create a safe water in the ground. That's the asset. We now look at a toolbox of nature-based solutions that extend from the natural areas, forest retention and natural wetlands towards the whole city. So they look at how can roofs, streets, squares not only collect the rainwater, but how can we actually make water available 24/7 and tap into the resource of wastewater. So that's also what our pilot looks like. So it's combining it's going from a situation of scarcity to a situation of abundance by actually changing the business as usual to a water balance model. Now, how does it do that? It looks at far away resources that actually are consumed, are mostly untreated, are flowing into the sea, diminishing and polluting the aquifer and lead to this water scarce situation. And actually by introducing nature-based solutions to collect, to recharge, to treat, and recycle water, we can reduce consumption and we create a safe water situation. So the idea is here that the city and the citizens themselves can provide their own city with a service that is to create a safe water situation. So we proved this with a demonstration model that was constructed between 2021 and 2023 in a school for the blind and deaf. We're looking here at a site of around 4 hectares. We have around 700 children that live and go to school here. We have a site which has the same urgency as the city itself. So that is flooding during the monsoons, but also backflow. So that means that the sewer actually overflows and comes out and creates very unhygienic situation. The topography in Chennai is very flat. So the standard grid system does often not work and leads to situations like this. So we're looking at a design for recharging rainwater with recharge wells across the campus. And that is, let's say, this aspect here is more innovative at a design for treating and recharging the treated wastewater. So this is a site of around 2,300 square meter in the center of the campus, where we constructed a settler, an anaerobic reactor or septic tank. That is the stage 1 treatment. And then we have 2 subsurface flow constructed wetlands. And we have a water tank, and then we have an infiltration field of around 700 square meter, and eventually some discharge well to discharge the remaining into the aquifer. So we see here how actually the pilot is set up as a demonstration model, where actually everybody who visits, and that's very important for capacity building, can actually understand all the different elements, almost like reading a diagram. You see here the flow model next to what we've actually implemented. Now those grooves here in the ground you can't see anymore, because that is where the discharge pipes with the small holes are. That's where the treated wastewater is discharged, and actually then it functions like an irrigation system for the park that we see here. So the built environment itself is the communicator for new generations to understand that change is actually possible. And the pilot itself becomes in the city a campaigner for an improved biodiversity. So this is after 1 year, we can see these pictures here. And the amazing thing is we see here an STP, a sewage treatment station, inserted in the heart of the campus. So we're also removing or trying at least to remove the stigma of sewage treatment. Now, what are the primary benefits for this pilot here? That a model of decentralized wastewater treatment and aquifer recharge was actually built and can prove the safe performance. And that we close the cycle with a recharge of rainwater that is also leading to flood mitigation. Then there's a number of secondary benefits for this pilot. So we can use it for citywide awareness building with events, capacity training, and media. We monitor annually on an annual basis the flora and fauna. We can prove a cooling impact on the microclimate. We have an increased carbon sequestration, not only by the green cover, but also because all pumps are supported through photovoltaic solar electricity, which results in a net zero carbon energy footprint of the sewage treatment and the rainwater collection. And we demonstrate a closed water loop connecting several nature-based solutions within one location. And according to our local team, this is really the first time everything is integrated in a closed loop. We have now a maintenance plan, a 3-year maintenance period, which is subsidized by the Dutch government, after which we're looking for local financing. So that means in this case, we have a gardener and 2 specialized staff for a normal maintenance, so removal of dried leaves, multiplication of plants, de-weeding, cleaning the grease trap, washing the disc filter, replacing activated carbon in the carbon filters, replacing the sand in the sand filters, and then on an annual basis, desludging the anaerobic tanks, and the electrical maintenance for the pumps and controls, which right now is actually where most of our attention goes, to the electrical system. We also have an operation and maintenance manual to provide detailed instructions. And this is naturally so because the performance of this piece is really all what it's about, so that we can prove that within the city we can reach same performance as with STPs outside the cities.
So we have here water chemistry samples that are gathered every 4 months that include parameters such as pH, chemical oxygen demand, you probably all know this, biochemical oxygen demand, suspended solids, etc. So we all within the standards. We have created an online monitoring platform that is connecting all the elements of the closed loop. So that's a quantity survey that we see here, a flow meter, and a quality is basically by hand every 4 months with a composite sampler. To basically keep the flow in check is very important, because we see here an interesting fact that while the campus is fully occupied, as we actually irrigate the plants, and of course the constructed wetlands also need continuous flows, we have actually a better level in the aquifer. So it's higher when the campus is fully occupied, and when the campus goes into vacation period, we have actually the level in the aquifer, which is here, which is minus 4.5 meter, is actually sinking. So through that, we can see it does work.
Thank you. If I sorry,
Yes.
just a friendly reminder, if I could ask you to start beginning to
Thank
wrap up
you.
in again a minute or so,
Yes,
again, just to be
in
fair
a
to
minute,
everyone else.
yes.
Thank you so much.
Thank you. So we have certain issues like lack of trust and awareness. We have, which we resolved with visits. We have, for instance, diluted influent by rainwater infiltration. So this we solved with effective microorganism treatment to accelerate microbial activity. We used the pilot to actually also for a political outreach. That was the opening. We have very positive response from the press. So therefore the pilot actually is functioning within the city, even though it's very tiny, to create knowledge locally and internationally, and eventually also as a proof of concept for the upscaling of nature-based solutions within the city of Chennai. That is so important. So that is part of our initial plan to upscale. So this was the initial water as leverage trajectory, the pre-feasibility. Now we've done the field trials, and now we're looking on a new upscaling of the project City of 1,000 Tanks. Thank you so much for listening.
Thank you so much, Eva. Very much appreciated. And lovely acronym. I like the 1,000. I was a little curious to see what the city of 1,000 tanks would be, but now it's clear and clear benefits for that. So with that, let us turn to Ralph Schielen, please. Ralph is with us here today, and he's a senior advisor at Rijkswaterstaat and a senior researcher at Delft University of Technology. Ralph has a PhD in mathematics and applies nature-based solutions to develop resilient river landscapes, and has also co-authored the International Guideline on Natural and Nature-Based Features for Flood Risk Management. So Ralph, thank you so much for joining us in person, and the floor is yours. If I could ask you again to target 10 minutes, that'd be appreciated.
I'll try to keep it within 10 minutes. Thank you so much for the introduction. Thank you for the opportunity to speak in person also, so that prevents all kind of IT difficulties. Yes, and this also works very nice. So we are going to Europe this time, and we are going to the Netherlands. So setting the scene, Washington over there in the West Square, Europe, and then focusing on the Netherlands. Very low-lying country. Highest point is about 300 meters. So I think we are in the top 5 of countries with the lowest highest point. Think about it. And in that, see this website. So in that country, in 1993, 1995, some things happened. We experienced very high discharge in our main river system. You see the video playing. The water is between the embankments, near and very near to the crest of the dikes. You see the low-lying land beside the dikes. We had to apply sandbags in order to prevent from flooding. So this was for a country as the Netherlands, which was very fond of its part on its water management. This was really an enormous wake-up call. We had to evacuate over 250,000 people. And after those events, we thought, okay, we have to do something in order to keep our safety standards. In the lower right picture, you see the process. I'm not going to talk about that. That will take me more than an hour. Although it is a very interesting process. What I want to focus about is actually that. So after the events of 1995, we did many calculations to show how big the problem was. In the period from 2002 to 2007, we did the policy preparations and the actual construction of 34 different measures. I will show them in a minute. Took place between 2007 and 2017, so within a period of 10 years. Total budget was about 2.3 billion euros, and the various measures they range between 10 and 380 million euros, and the amounts in dollars are in the brackets. Okay, so what's the Room for the River? It's a coherent set of measures. So the coherent aspect is quite important. We could not just choose sub-measures. We did a system analysis, and then we kind of placed all the different measures that were needed in order to lower the floodwater levels, to get again to our safety standards. And that resulted in these 34 projects distributed over the river branches as a whole. And it looks something like this. So we lowered floodplains, we created side channels, we removed obstacles. Sometimes we relocated the dike, so we increased the floodplain itself. And the important and key thing for this presentation is to acknowledge the fact that Room for the River is a demonstration of nature-based solutions, because the Room for the River program leads to the reduction of the flood risk, because it reduces the floodwater levels, but simultaneously we increase economic activities, we increase biodiversity, which we also shows by scientific research, enhanced flora and fauna. We basically added to the general well-being, and that is actually within this definition of nature-based solutions. So we are solving for one problem, and then we are looking at many corporate benefits that these measures have. Yeah, just show one key example, which is a large flood side channel near the city of Nijmegen in the eastern part of the Netherlands at low discharge, where you see the side channel and the opportunities that the side channel brings. And here you see it with high discharge. Okay, and again, so lots of co-benefits for farming, for recreation, strolling and wandering in the floodplains. Also leisure, although this is not really permitted, I should say, so this is perhaps not a photo that you should use. But people do this, and well, they have a lot of fun in these new created places. Now, so what about the maintenance of the Room for the River projects? For that, I should say that Room for the River was, so it came about due to this high discharges that we had the policy process, we defined the measures, and they were constructed. And construction is really the key thing of this project. So it was a construction project completed within budget and time limitations, which was also quite exceptional actually at that moment in time. And at the end of every individual project, we were looking at these kind of circumstances. So we added some space to the floodplain, we created these side channels, and eventually we left that in a kind of bare, so very bare situation. Knowing that after some time, of course, the vegetation would grow, and then we would get to the end stage that was designed with this various vegetation that we planned actually. But we also knew in advance actually that after some more time, the vegetation would just continue to grow, and perhaps also some willows would start to exist to grow over there, and it would become bigger and bigger, and the floodplain would get rougher and rougher, and then we perhaps might lose this element of the flood reduction. So, but again, this was a construction process. So at the end of the project, well, we get applauded, and everyone said, okay, this is just not a great achievement. When we looked at the maintenance, okay, well, let's cross that bridge when we get there. And of course, that took a few years, because in the initial stage, well, there was not so much to maintain. But now, actually, we have reached that bridge. So we are looking again, for instance, at one of the examples of Room for the River. So this is along the River IJssel, which flows to the north. You see the construction of the many side channels, and we also see the vegetation that now grows on there. So at this moment, in particular in the Netherlands, we are dealing with let's say, the regular operation and maintenance of all the floodplains that we have in the Netherlands. We have the additional operation and maintenance of the newly constructed Route for the River projects. And then we also have the construction operations and maintenance of water framework directives. And the water framework is a European project that tries to improve the water quality. And that also involves many side channels, for instance. So we have a lot to do about that. And for the future, we are looking at another scheme of measures that we want to implement in order to guarantee also the safety for the longer term, 2050, 2100. So that means additional projects in the floodplains, which need to be maintained. So who is responsible for the operation and maintenance in the Netherlands? Well, that is primarily Rijkswaterstaat, which is part of the Ministry of Water Management, and they are just responsible for the complete area between the main embankments of all the major river branches. And it doesn't matter whether Rijkswaterstaat is the owner or not. The maintenance is about, well, the issue of flood management and flood safety. Of course, we want to keep a safe situation, but also, as I said, about water quality, and also about a kind of societal functioning, because we allow, of course, people to go into the floodplain and well, do their picnics over there, do their recreation, and of course, we want them to be safe. But it also means that we have to do some actions in order to guarantee that. So the operation and maintenance itself looks like this. So we are looking at the state of vegetation. Whenever that becomes too high, it causes too much friction, and then we have to interfere. We do that by mowing, sometimes by drastically cutting down trees that have become too big. We ask the farmers to keep their crops low in the winter, such that whenever the floodplain flows, and that's of course one of the primary functions of the floodplain, that the flood water levels are not too high. Okay, now zooming in on operation and maintenance of side channels, as this is one of the things that is in the document that was mentioned by Def and Matthijs. We have approximately 150 kilometers of side channels, and they originate from all the different programs that I just mentioned. So there's an example. This is actually a combination of 3 individual side channels. And we know also from scientific literature that eventually they all close off. So whenever the floodplain is flooded, that brings sediment, and eventually that fills up these side channels. So that already indicates that all these side channels have to be maintained. Well, as an example, we are looking at one example on the Waal River. It's depicted over here in this inset. Lower left, we see the actual situation of the side channel as it is. Very beautiful place, very biodiverse, I would say. And then if we cross let's say, the area to the inwards to the screen, we come to the main river with all the big shipping activities. Okay, so we have to maintain that. In order to do that, we define some elements. So we define the element of free space, which is the contour between which the side channel itself may move. We have the free volume, so the total volume, the threshold for the total volume of the side channel, and also the minimum depth. And these are all indicators that we monitor, and that whenever they are violated, we have to do something, so we have to interfere. And that means, for instance, that we have to dredge the system, or we have to dredge parts of the system. So red means dredging, and blue means that is already high enough. And just by doing the monitoring, we see what kind of maintenance we need to do. And then we need to do that 100 times because we have so many side channels. Can you click on this movie? Here's an example how that is done. So this is not construction, but this is maintenance. So we did the monitoring, decided that this side channel was not deep enough anymore based on LiDAR images that we have, and then we decided, okay, so we have to maintain that, and this is the way that is done. Okay, we monitor also the vegetation in the field just by drones and other ways, and we compare that monitored vegetation to the situation that we wanted to have it in theory. Whenever there is a distinction between that, also an indication that we have to interfere. So some facts and figures about that. Well, many owners, many municipalities, many stakeholders, and we have about 25 million euros for the annual budget for the maintenance. Now, what about the international outreach? we are trying to the experience that we have from the Netherlands, we also try to translate it to other countries like Bangladesh and also Colombia. And the main thing that we want to transfer is do not only think about construction, but also think about maintenance. Conclusions, it already gets much attention, but you need to do more. For benefits are massive, but you need to quantify them, and the experiences can or should even be exported nationally. With that, I would like to thank you.
Well, thank you so much. So I think we've had 4 wonderful presentations. And again, I really want to thank those joining us virtually, but also in person for these really, truly, these great and very informative case studies. We now have our discussant, Paula, who's going to walk us through a bit, what we've heard and to provide some synthesis. Paula, of course, is our lead urban specialist in the Urban Resilience and Land Global Practice within the bank. And within the sector, she has worked on areas related to territorial development, urban infrastructure, municipal finance, and housing as well. And she's led or contributed to investment projects in Europe and the Central Asia region, as well as the Latin America region as well. And Paula, before we turn to you, I unfortunately have to excuse myself. I have to run to my next meeting again, but I trust that the team will be here to sort of help to help wrap things up. And again, just my sincere thank you for allowing me to participate and learn as well. And then best of luck for the rest of this BBL. So thank you so much. Thank you.
Right. Thank you very much for inviting me. I think this has been a very interesting discussion, and to have all of these case studies from different places. I'm just going to do some initial reflections from what we find on the ground when we try to initiate NBS. And this will come from a different set of countries, from Haiti, which is a fragile state with very specific context, to Brazil, Bolivia. So in each place, we need to understand the context. And I think that's one of the things that is important. One first reflection, and I think some of you mentioned it, is the importance of thinking about this from the design. And it's not only about how to bring some of the best practices from different places, but to really have an understanding of the context, because many of the very nice design features that we can think about, once you get to operation and maintenance, they don't work. So that's in the context where we work. Just to give you a sense, for instance, in one of our projects in Haiti, we have families that use the waterways for their livestock to feeding. So every plant you put there is going to be destroyed very soon. We have almost in some of the places, like in Cap Haitian, where we have a number of projects, there's no solid waste collection. So waterways, the sea, everything, every free space is where solid waste is disposed. So that also generates some challenges in terms of putting in place nature-based solutions. You have often wood, be it from mangroves or trees, used for cooking still, even in urban areas, or for selling in the markets. And you have very, very little capacity from the local governments, cities growing very fast. So it's not only about how do you create these spaces, but how do you protect those spaces from urbanization. So these are some of the contexts. Not every country is like this, but this is just maybe one of the most difficult examples in which we have been trying to implement nature-based solutions. And the last thing that I think some of you mentioned then is on responsibilities. Who is in charge of designing, of the institutional responsibility of putting in place these measures and the investments, and also in operating and maintaining them? We see that in some of the client countries, it is not, for instance, the areas of urban drainage. It's not as clear who is responsible. Sometimes the rivers go with the federal central level, but urban drainage and the connection between the urban drainage and the rivers, it's not as clear. So there's a whole aspect in terms of identifying those responsibilities, and sometimes using our projects to do some reforms and making sure that it's very clear who is responsible of what. So those are our first couple of things. And the last thing that we have a challenge that maybe some of you don't have as much is that sometimes our projects, they span over 5 or 6 years. And By the end, if we're lucky, we have all of the structural and non-structural interventions put in place. The trees are not that big, so the operation and maintenance is something that we really need to think and build during those 5 or 6 years, so that when we leave, it's maintained, it's sustainable. We have found a lot of similarities to what some of the case studies that were mentioned, how important it is to bring community, and this is sometimes in local universities, the schools as well, so that they occupy the space. The private sector is something that I didn't hear. I heard a lot today, maybe from the San Francisco case. We have seen that the private sector can play an important role, not only in participating in those technical committees, but in some cases, for instance, in cases such as also like Haiti, they can play a role in operating and maintaining in some of the spaces. Sometimes you have heard in the US and in other places, like adopt a mile. There are things like that we see that they can work in certain contexts. We are also starting to see how, in particular for urban parks, how we can put in place mechanisms from the design of putting building some restaurants or some commercial activities and renting it out. And so that allows the funding that is generating through those rents to maintain the park, or even assure that there's some security around it so that you don't get those spaces urbanized. So these are just some ideas. There's some elements in some of the countries in Brazil where payment for environmental services, in particular, if you have a very clear beneficiary, in terms of, for instance, if there's a water utility that is going to benefit from some of these NBS, that's something that we have also seen. And maybe the last thing that I wanted to mention that we feel is also very relevant is, and some countries are more advanced than others in terms of implementing NBS. But in general, it's good to start small and with a pilot so that you learn through it, that you systematize. Okay, how do we create manuals to incorporate NBS in the design of flood risk reduction investments, or in the design of urban corridors across the city. So starting with those pilots is a good idea, because it allows you to solve a lot of these questions. Who is responsible? How do we do it? How do we create, like in Chennai, these examples, and that people now start to understand it? How do you make sure that some of these responsibilities that sometimes at the local level are split, because you have all of the engineers that tend to be in the public works secretary or ministry, and then you have a lot of the maybe environmental engineers, biologists, ecologists that are in the Ministry of Environment or in the Secretary of Environment locally. So how do you create those mechanisms so that they together look into this type of solutions? And one thing that I think was, a challenge from what I see is how important the cost of maintenance is in some of the case studies that were mentioned. I think that is something that it would be good for this community of practice to also continue taking a look and to get some sense on what are the costs in terms of maintenance. Because I do think it is important to be very realistic upfront. To fully understand if what we're designing and investing in can be maintained and who will be responsible to finance that. So that's all. Thanks for everyone.
Thank you, Paula. That's great. Yeah, and so I'll be your stand-in chair for the last few minutes. For those who are online who might not know me, I'm Boris van Zanten. I'm co-leading the NBS program from GFDR. So yeah, as might have been expected, we're running a little bit over time. I think I would like to still, we have had a lot of presentations, so I would still like to open the floor for some questions, and then we, might wrap up a few minutes late. So yeah, did we get any questions over the chat? No questions over the chat? Okay. Yeah, well, let's just open it up and see if something comes up. So if anyone online or in the room, if you have any question to one of the speakers or the discussant. Now's the time to talk. Right. Sometimes you look far away. It's close, right? Yes,
So just
right.
Mohamed Bhaskar with NOAA. There are a couple of points I thought I should make a mention that I was hoping to hear more of. This is just a feedback input, something to think about for future. And the first one is, redefining success and failure. I think that when you have a nature-based solution, failure is really not a failure. Given enough time, nature will actually switch that failure to a success. So that aspect of it, I think, is extremely important to recognize. And so the way I call failure is their success in progress. It's going to so that aspect of it, defining or redefining success and failure for nature-based solution, I think is very, very important. The other point that I think one of them mentioned, the Army Corps person mentioned it, and that is adaptive management. Because when you have the best laid plans, nature has a plan of her own. And so, many times that adaptive management could be that smallest little thing that can change what could be potentially a failure into success. So what I mean by adaptive management is going back and looking at, maybe a year later or so and seeing what kind of imprint nature has actually left on that project, learning from them and tweaking it a little bit if they have to. So those are two things that I thought. There are a lot of mentions of other things, but these two things I just wanted to put it out there.
Thanks. Yeah, that's a very good point. Yeah, I think we've seen several examples of projects that turned out different than how they were intended initially. Yes. Any other questions? Perhaps online, or we have here in the room one question. Yeah, Hans.
Well, I also wonder that if you look at traditional gray infrastructure, we think monitoring maintenance that's normal. And with nature-based, it seems to be that we have to squeeze ourselves in all kinds of corners to make it normal. So why is that? I don't expect an immediate answer, but I think that's something we might have to wrap our heads around.
With that, I think there's also been the messaging that nature is like adaptive and sort of self-adaptive, self-monitoring, so that we don't necessarily have to put in as much effort into the monitor or into the maintenance and monitoring, which I don't think is necessarily true. I think there is an aspect of that, but I do think that our messaging has kind of been a bit mixed in what the sort of aftercare is for these kind of projects, so that now we've kind of found ourselves in a difficult position of, we do still need that additional funding for, maintenance and monitoring that we just didn't necessarily think about when we started.
Yeah, maybe is there one of the speakers who wants to respond to this question raised by Hans, or maybe the discussant?
I can add something, just also from one example. So in La Paz, in Bolivia, we have within the municipality secretary on disaster risk management, and they have been doing structural interventions for, I don't know, more than 20 years. They have these manuals. They know how to maintain gray infrastructure. No, they come with their bulldozers. They take out the sediments just before the rains come. But once you put NBS, the manuals and everything, that's just like not in the system. No? So there has to be, like, we're creating the first pilots. Okay, how do we incorporate NBS into the design? How do we start operating and maintaining that specific pilot? And then how do we move that to systematize, as part of their operating and maintenance of their whole pluvial system, to embed it, as part of their institution. So I think in some places maybe they're more advanced, but these are the type of discussions that we're having with some of our clients. They're having a hard time understanding, once they pass from gray to nature-based, what it means in practical terms, what they need. If they need, instead of, I don't know, 3 civil engineers, and this amount of that, if they need new skill sets.
Yeah.
I understand there is a hand up online. Tom, you wanna you want to also respond to a question raised by Hans?
Yeah, I would like to respond to that. I have the feeling that the maintenance is very different per discipline. For conventional gray infrastructure, you have different disciplines who know how to maintain that. But for green infrastructure, other disciplines really well know how to maintain that, but it are different people with a different education. So it's really important to have those people on board as well with their knowledge, but also that they take up their responsibility to explain how to maintain nature-based solutions. From background, I'm a hydraulic engineer, civil engineer. I don't know that much about mangrove trees, but there are a lot of people who did their environmental or ecological studies who very well know how to do that. So please involve the people who are expert on those topics.
Thanks, Tom.
Jeff? Well, I guess I would argue that we're not that great at maintaining conventional infrastructure either.
That was exactly what I was thinking.
Jeff is with the Army Corps of Engineers.
That's right. That's right. And you can look at what the American Society of Civil Engineers puts out every year in terms of the grade that in their report card that we get for infrastructure. And we're typically at C- or D+ at best. So it's not just nature-based solutions, it's also conventional infrastructure too. And so I think there's a lot of work that needs to be done on many levels, and in many ways it comes back to funding and thinking through, how do you articulate the message that monitoring and adaptive management needs to be baked into the entirety of a project, not just the design and construction phase. And then the other thing that I found very, very compelling is the case studies that were offered today, and then thinking through all of the case studies that I've been fortunate enough to learn about over the years. And we have to find a better way of getting those kinds of examples out to parties that are interested in pursuing a nature-based solution project. I think those kinds of learnings become inherent to progress and being able to get to success. And it is a function of offering a lot of detail when it comes to how you design and construct these type projects, then also where we have been successful with inclusion of adaptive management and monitoring and maintenance, those examples also have to be fundamental to the case studies that we offer.
Just want to add one more point.
Okay, we take one last comment from Eva, and then we
Vivian
jump.
also.
Vivian Depade?
Yeah.
Okay, we take those two online, and then we take one comment, and then we'll wrap up. Okay. First, Eva.
Yeah, thank you. Yeah, I can completely relate to that need to repair existing infrastructure. It was one of the biggest roadblocks for our project in Chennai, to actually the lack of documentation of what the existing network of the school actually looks like, and the lack of being able to understand and connect by means of an overflow to the existing grid and the desolate state of that. So where, let's say, nature-based solutions, I'm talking about the urban case, meet the existing and how we connect those two, that's kind of a big headache. And also for, let's say, building up trust. We've heard it already today with many projects. The time span is very, very long, and the caretaking is very, very long, and it gets better the longer it takes, but government terms are very short. And so there is really a clash with how our political system and investment in stable relationship is sort of linked. It's almost each time we go back to Chennai, we have another team in place. And so how we can bridge this, I think this is a quite crucial and interesting question. And we saw it from Terry also, that local communities are the most stable people in place.
Yeah. Point well taken on institutional change and stability. Yeah. I think Vivian, you want to come in? Do you have a question to one of the speakers?
Yeah, thank you, Boris. And actually, the question was for Eva. I think I was quite interested in the gray water treatment solution because indeed in urban area, I work in Abidjan in Côte d'Ivoire. I'm a senior urban specialist. Most of the water is gray or wherever you are because there's always some mixing. And when we have kind of retention areas, there is always question, what's the quality of the water? Can we let it sit there or not? And doing it with purely plants is, I mean, you need larger areas from what I understood at least, and it's not very feasible for smaller kind of urban parks in dense cities. So I was quite interested if you could develop a little bit that solution you mentioned to treat the water, and also what kind of requirements there are in terms of operation and maintenance, in terms of skills and financials and so on. Thank you.
Okay, it's a very large question. I'm gonna go very short. So there is a ratio between per person rate and the size of a constructed wetland, equally the size of the anaerobic treatment, so the septic tank and the settler. And that ratio also depends on the climatic conditions. So basically, in warmer countries, it works in a more stable way than in countries with a very cold winter, when bacteria basically go to sleep. And in principle, nature-based solutions, they want a continuous flow. So situations like in a school where we have a very a kind of almost no flow during the summer month, we needed to bridge that by actually with a recirculation line to actually keep on making sure that the plants have water. So we recirculate that. So that's switched on manually during the times when we don't have this flow. In terms of cost, I can only give the cost, which I didn't put in the slide. It's $645,000 for the building of this closed loop pilot, but that also includes a lot of R&D money. We have, I think we had here 12,000 per month for monitoring per year for monitoring and maintenance, 20,000 per year. And this, of course, there is an economy of scale to be made that when such systems get multiplied. And I also believe that in this case, even with AI and with actually having the help of AI to multiply, let's say, the benefits, there could be a great connection be made, because the question is, why hasn't it been implemented in the urban context so far? Because it's incredibly hard to piece, let's say, the performance together to reach the same performance of the large scale systems. And so I think that's an interesting challenge for the future. So that's just answering a part of your question.
Thank you, Eva. That's a great answer. And if Vivian, I hope it helps you with the answer. I think it's great that there's so many questions. I think we could go on for a bit, but we really need to wrap up. So give people some time to have a coffee and take a break. Before we do that, one last comment?
One last comment, yes. We were talking about green infrastructure and green infrastructure.
Might got closed in the room, I think.
Sorry about that.
And, with nature-based solution projects, the worst day it's going to see is after the project is put. After that, it only gets better because nature actually takes over. So just want to leave that final note.
Thanks. Great. With those wise words, and yeah, I think very true. I think you want to do a few closing remarks? Okay, so we're almost there. So actually, we had a small change on the agenda. We were supposed to have Joe Mannes, director of the Institute of Water Research. Am I saying this correctly? Unfortunately, had to drop out today. So luckily, we found a more than worthy replacement. Jeff King is the national lead of the and program manager of the Army Corps Engineering with Nature program. and actually, of course, have a long-standing relationship, work together on the international guidelines, and the engineering with nature, civil works, and military portfolio has a combined value greater than $25 million. So yeah, Jeff, I think you've been working a long time in this space. First together with Todd Bridges, of course, more than 20 years in positions with NOAA and the Army Corps, and of course was one of the co-leads in the development of the international guidelines. So with that, maybe you can give us a few closing remarks.
Yeah. Thank you.
And tell us
Great.
about your impressions.
Great. Well, thank you to the World Bank for hosting this event and hosting on such an important topic. And I'd also like to thank the presenters for sharing their projects with us and allowing us to learn from their examples. I think that, from where I sit within the Corps and our partners have long recognized the value of nature-based solutions, and it's partnerships like what we're talking about today, partnerships like this International Nature-Based Solutions Work Group that have really focused on these valuable efforts, much like what we did with the international guidelines for use of natural nature-based features. So all that said, and certainly when you heard the questions that were offered here in the discussion section, there's still a lot of work that needs to happen to fill these different gaps that will ultimately get us to where we need to be in order to fulfill our desire to see nature-based solutions be incorporated in all water resource management projects. So we got a lot of work to still do, but we're getting there. And I think that's the important point to recognize here today. And certainly the projects that we heard a lot about today offer a testimony to what is possible and the good news that is out there. So in the interest of time, I'll just close by saying, it's these kinds of collective learnings that are key to successfully advancing the use of nature-based solutions in water resource management. And certainly we look forward to continuing this collaboration to exchange knowledge and collectively work towards our overcoming these challenges and ultimately achieving lasting success. And again, I want to thank the World Bank. This was a fantastic event. Appreciate you hosting it and look forward to future events as well. Thank you.
Thank you, Jack.